The independent events A and B are such that the probability of A is 0.2, the probability of A union B is 0.4. We want to determine the probability of B. Okay, in order to determine the probability of B, we're going to be using the addition law. We're going to have the probability of A union B equals the probability of A plus the probability of B minus the probability of A intersect B. There's a couple of things that can help us in this question. First of all, life becomes easier if I use the probability of B is equal to some algebraic variable, let's say x. Also, it's really important that we acknowledge that we have the independent events A and B. So what this means is probability of A intersect B is actually equal to the probability of A multiplied by the probability of B. Remember, you can only use this if you're told that we have independent events. So let's start substituting values into our addition law. Probability of A union B is 0.4. Probability of A is 0.2. Probability of B is x. Probability of A intersect B is the probability of A, which is 0.2, times the probability of B, which is x. Okay, so I'm going to subtract 0.2 from both sides and tidy up these x's. So on the left hand side I've now got 0.2, and this is going to be equal to x, take away 0.2x, which is 0.8x. I'm going to divide both sides by 0.8, and we'll get a value that x equals 0.2 divided by 0.8 is a quarter, and in this case I'm going to write it as a decimal because it's going to help me for part B. How do we get marks in this question? Well, first of all, we get a method mark just for identifying that we are going to use the addition law. Second of all, we are also going to get a mark, and lowercase m1, if we identify that we can use the probability of A intersect B as the probability of A times probability of B. Now, only if I've done that can I then get the mark for doing correct substitution into the addition law using this statement here. So we get an accuracy mark at this stage here, and then finally we get our accuracy mark for x equal to 0.25. Part B. Part B wants us to calculate the probability that exactly one of the events A or B occurs. Well, the easiest way to approach this question is if I draw myself a Venn diagram. So I'm going to have the events A and the event B. There is an intersect. Event A, event B. I know the intersect is 0.2 times 0.25. So when we do 0.2 times 0.25, we get 0.05. That means the probability of A with this 0.05 must have 0.15 and this left part of the set, because they must total up to 0.2, and the probability of B on the right part of this set must be 0.2 because this has to total up to 0.25, and then probability outside of this then is 0.6. Probability that A or B occurs in this case is, well, this section here, this relates to only A happening, this section here relates to only B happening, so what we have is 0.15 plus 0.2, which gives us an answer of 0.35. Okay, how are we going to get our marks here? Well, marks are going to come from demonstrating that we are going to have this calculation here. So method 1, actually 1, having read from the Venn diagram, and then we're going to get an accuracy mark for the 0.35.